skills in the data world using Python. We are very, very glad to introduce you to two women in this occasion that contribute actively in the data world and want to share this knowledge with us. Sorry. So first, we must remind everyone our code of conduct. Please keep your microphone muted at all times. After every talk, we will have a 5-minute space for questions for our speakers. So please feel free to do them through our chat, and at the end, we will formulate them for them. Because of this, we expect that everyone to communicate in a respectful and constructive manner, please. So, and because it's an online conference, we have to move fast. So whoever violates this code of conduct will be banned. The last part, of course, is the legal consent. So this talk is being recorded to distribute around our social media. So when you register and participate in our events, you are agreeing that your image, name, or audio can be used. If you do not agree or want to be excluded of this, please tell us through our chat. So we invite you to share your experience and inspire and help other women. So remember to mention us at Magenta Codes and also Women Tech Makers with the hashtag More Women in Tech and More Women in Data through Twitter, Instagram, and Meetup. So if you agree, it's time to take our group photo. We are breaking down barriers, so a good photo will remind us of this. Please, everyone who is agreeing, turn on your camera, and we will take some photos of the event and share it. And please feel free you also to share your experience with us. Is Joe ready? Okay, perfect. So this is the schedule that we have today. We are gonna give you guys a quick introduction on who we are as a community, and then we will have a talk, the first talk, with our first speaker that is Naomi Sitter. It's called Iteration Inside Out. And then we will have 10 minutes, a 10-minute space for questions. So remember, do them through our chat. And our second talk, it's by Julian Sarah Joseph. It's called COVID-19 Data Visualization using Python. So please also feel free to do your questions. And at the end, we will have some closing remarks and our goodbye. So a bit of who we are. Let us introduce ourselves. We are Magenta Codes. My name is Alejandra Ferreira. I am from Colombia, and I have been living in Sweden for a year. I am a microbiologist and a full-time mom, and decided to start and transition my career to technology. Currently, I am working for a legal startup and as a project manager and full-stack developer. And I am today's moderator. So, and we have the rest of the team here. So please feel free to introduce yourselves, girls.
Hi, everyone. My name is Dunia Rivas. I am from Bolivia. I have been in Sweden for more than a year. I studied system engineer and I have worked as a data engineer in my country. Currently, I work remotely for a company in my country as a recruiter, and I continue studying in data engineering and also in English.
You are muted, Joa.
Okay, hi everyone again. I am Johanna Salinas. I am a system engineer student, and I am lead in the data science experience from
Hello, everyone. My name is Luisa Giraldo. I am from Colombia and have been living in Sweden for more than 1 year. I am full stack web developer and now a part of this community, hoping we can all grow together. Thank you.
So yeah, let me tell you how Magenta Codes started. We are a couple of expat women that decided to enter or already in the field of technology, and we realized that we were facing different barriers accessing information, education, and job opportunities because of the immigrant status, also being full-time parents, some of us, and in a new country. So we decided to exchange some ideas and try to create this community to uplift women, help them with their barrier languages and on technology topics. We are also in alignment with the UN Sustainable Development Goals, specifically for goal number 5 related to the gender equality. And we are also under the wings of Women Tech Makers, that is a Google's community that supports women in the tech ecosystem. So, we have our first talk. I want to introduce you to our first speaker, that is now Miss Heater. She earned a PhD in classics several years ago, but she switched from ancient human languages to computer languages sometime in the last century. Since 2001, she has been learning, teaching, writing about, and using Python. She is an elected fellow of the Python Software Foundation. Naomi currently serves as chair of its board of directors. She also speaks internationally about the Python community and on inclusion and diversity in technology in general. She has over 25 years of professional teaching experiences, is the author of the Quick Python book. She has also a tested and broad knowledge on Python. Her particular forte is teaching coders new to Python, quickly bring them up to speed in patterns and syntax, but also in Pythonic practices and culture. By day, she also leads a team of Python programmers for Dick Blick art materials, and in her spare time, she enjoys sketching, knitting, and deep philosophical conversations with her dog. So Naomi, welcome.
Thank you. Thank you. Delighted to be here.
You can now share your screen, yeah.
Okay, let's see. I'll present now. There we go.
Exactly.
Window. Okay, just one moment. I'm sorry about this.
No problem.
I upgraded my Mac to Catalina finally 2 or 3 days ago, and I continue to get reminders that I need to change the permissions. So this is not a horrible thing. It's just a minor thing here. So let's see here.
No worries. We all have been in that position, updating and upgrading and things like that.
And I can actually probably sort of half talk while I'm doing permissions here. The thing that I'm interested in, as you said, I mean, thank you for the very kind introduction, was, let's see, screen recording. It is not, it's not letting, let's see if I can, window. There we go. All right. Now what I'm going to need to do, sadly, is I'm going to need to quit Chrome and pop right back in. So I will be back instantly, I promise. But I need to do that. So
okay, no worries. We will wait. Thank you, everyone.
Wait. Maybe I do. Maybe I don't. Wait a second. Can you see my screen?
Yes.
All right, then the Mac OS lied to me. That's totally fine. We'll roll. Okay. This was actually last night. I gave a presentation to a group in Panama. And I was going to prove to them that if you pre-compiled your regular expressions, they would run faster. And for the first time, and I don't know how many hundred times, they did not. So anytime you do presentations go live, things happen. So we will go ahead. So yes, I thank you again for the introduction. If you're interested in this notebook, basically the place to go to get a copy of this Jupyter notebook or other stuff would be github/ncedar. This one lives in a repo called workshops. So GitHub ncedar workshops. There is a copy of this that you can play with on your own. And I love for people to go ahead and play with these things. If you even want to play with them while I'm talking so that you can raise questions, I'm fine with that. So I want to talk about iteration, which is, as my friend Dave Beasley put it, Python's most powerful, useful feature. And he said this when he was giving a remote talk to PyCon Pakistan a couple of years ago, called The Unauthorized Biography of the For Loop. And if you want to look that up, you can also see Dave Beasley, one of the sort of legends of the Python world, playing the Monty Python song on his trombone. So I highly recommend it. But what he means is that iteration is sort of unappreciated, but it is used everywhere. And I would argue that it's also not very well understood. So what I want to do is actually kind of go through a little bit. Wait a second here. I need to make sure I'm doing this in the right order. Go through a little bit about iteration and how it works. So there are lots of things that we do in handling data where we're actually doing the same thing over and over again on a series of elements. And that could be temperature readings for a month, dictionary keys containing user information. It could be a CSV file with 1 million products. I've actually done that. It could be the text of a long novel like Moby Dick. It could be a result set of a database query for yesterday's sales or whatever it might be. And when you think about it, these things don't have a lot in common in terms of their contents. They also don't have a lot in common in terms of even the kind of objects that they are. So, you know, dictionaries, lists, database queries, text, files, they're all different objects, but they're all things that we want to look at one item after another from them. And in Python, we would go ahead and use a for loop for all of them. So we would do various things. As I say, just showed you here a typical Python for loop. I didn't mean to do that. One moment, please. There we go. I wanted to get back to where I was here. There. We have a typical Python for loop. We would use that to access these items. And many people are probably thinking, well, yes, this is obvious, right? We use for loops in Python and for loops behave the way they do. But this is actually a rather odd thing. And in fact, it's not something that, I am sorry here because I keep jumping around and I don't seem to be getting things in the right order. So let me see if I can do this. So this seems obvious to us now, but it used to be surprising. That is, the way that Python handles for loops was in its day kind of revolutionary. So here I've got a snippet from the Python documentation from 1994. So 26 years ago, and it talks about how the for statement in Python is different from what you would expect in C and Pascal. Rather than always going over a progression of numbers, which is what Pascal does, or letting the user do whatever they want, which is what C does, Python's for loop iterates over items of any sequence in the order that they appear, and that is a little bit surprising. So yes, we have a for loop here the way we would write it in C. And these days, not as many people know C as they used to. It was one of my first languages. You have this kind of weird construction here where you basically set a condition, you set a Boolean to check whether the condition is going to stay true or not, and then you change your loop variable so that you can step through. But in fact, out of this entire statement in C, the only thing you really need are the 2 semicolons. If you want an endless loop, you just put 2 semicolons in there, it'll do the same thing. Okay, well, this isn't a C class, so we can go ahead and kind of continue, but basically it's a shorthand for a while loop that will iterate over the items in the list. And you can do similar things in Python. So you could, if you wanted to iterate over a list, if somebody comes to the language from C or maybe sometimes from Java in the old days or other things, they have a temptation to want to do something like this. They want an index variable, and then they're going to get a series of integers for each slot in the list they want to iterate over. And to do that, they use len to find out how many numbers they need. And they do that to iterate over the list. And it works. But it's not really Python. It's C that is written in Python. So what should we do? Well, in Python, what we're more likely to want to do is do it the Pythonic way, which is using for and then just let it iterate over the sequence like this. Okay, that's fair enough. But the thing is, how does that work? How does the for loop know what's next? How can for loops work on the lines of a file and the keys of a dictionary and the items in a list? And if all of those things can be used in a for loop, what makes an object work in a for loop? How can I write one? These are the things that people don't usually understand about the way that Python does iteration. So the way that Python does iteration is it relies upon what we call a protocol, not on specific types. And this has been true for nearly 20 years, since about the time I started doing Python 2.2. It relies on a protocol that is on how things behave. And I'll explain the protocol in a second. And this is also, by the way, a good example of Python's use of duck typing. And if you're not familiar yet with the phrase duck typing, it's used because basically it refers to the old joke, if something walks like a duck and quacks like a duck, we can consider it a duck. And so anything that follows the iteration protocol, that is anything that has the right behavior, not type, but the right behavior, can be iterated over. And that is what I am going to show you. I'm going to tell you about the iteration protocol. The iteration protocol has 2 parts. You need an iterable object, and you need an iterator object. And those words are very similar. They're easy to confuse, but they do different things. So that's what I want to be sure we understand. So an iterable is an object that somehow contains something, like a list, like a tuple, like a file. And it is able to return its elements one at a time. With lists, we can use the square brackets. Same thing with tuples. We can get one element out of a list at a time. And the other thing that might make an object an iterable is that it will have a dunder iter method that returns an iterator. Okay, since we don't know what iterators are yet, we'll just put that on hold. But it can also be any class with a dunder get item, that is the thing that you get when you use the square brackets, with a dunder get item method that follows sequence semantics. And the last piece of information that we're going to see in play here is that a for statement, when you make a for loop, will create an unnamed iterator automatically. But that's one of the last bits we'll see. So let's move on. Restating, an iterable must return an iterator when the iter function is called on it. In other words, for that to happen, this is by definition of what the iter function does. It'll either call get item, assuming sequence semantics, and that means you access slot 0, slot 1, slot 2, slot 3, etc. Or it will have its own dunder iter method that we'll talk about soon. Okay, that's all kind of the background. I want to actually start looking at objects. So we've got our list here. And one way I want to see if it is an iterable is to ask if it has a dunder iter method. For that, I can use the function hasAtter, tell it what object I want to look at, and then tell it the name of the attribute that I want to see if it has. So when I do this, it will tell me that a list has a dunder iter method, so it must be iterable. Okay, that's fine. Or we can say, does it have a dunder get item? That follows sequence semantics. And that's a little bit harder to decide. And again, in Python, we can rely on the notion that it's easier to ask forgiveness than permission. And that is, if we want to find out if something is an iterable, we can just call the iter function on it and handle the exception. We don't need to worry about finding out first. We can just go ahead and try it. That's sort of the Python way we would do things. But right now, I want to go ahead and make an iterable from scratch so that you can see what happens. Because so far I've talked about theory. It's really hard to just assimilate the theory without actually seeing it in action. So here's what we're going to make. We're going to make a repeater. And if I make a repeater object and I tell it I want it to repeat hello 4 times, that should give me an object. Oops, I didn't mean to do that. That I can put into a for loop, and it will give me 4 hellos. Okay, so that's all we're going to do. There's not much to it. We just tell it what we want to repeat, how many times to repeat it, then we can put it in a for loop, and it should, quote, just work. Okay, so to do that, we're going to use the dunder get item approach here. And so I'm going to make a class here. And if you haven't done much with classes before, this one is pretty simple. So I'm class repeater. Okay, so that defines the class. I'm going to give it 2 methods. The first method, dunder init, is just setting up the values that I'm going to use. So here for value, that's going to be hello or whatever it is I want to repeat. And limit is going to be the number of times that I want it to repeat. It will start from 0 and go up to, but not include limit in terms of how many times it will repeat. So that's pretty simple, right? The other thing I'm going to create is a dunder get item. And this is what we would use if we were to try to get an item from it using square brackets. So it only takes the index, that is the slot number, the number of the element that we want to get. That's the only extra parameter it needs. And I'm going to make sure that my index is 0 or greater. If it's less than 0, that's negative indexing. We don't want to even go there. We're not going to deal with that. And I also want to make sure my index is less than the limit I set for how many items we're going to be in here. Okay, and you might notice this is a handy Pythonic way of doing that comparison that a lot of other languages won't let you do, is just to be able to chain these comparisons together. So if in fact index is 0 or greater and less than the limit, I can then return something. So if I said that I wanted hello 4 times, I can do 0. Yes, that'll work. I can do 1, 2, 3. Those will all work. 4, my limit is 4. 4 is not less than 4, so that will fail. And it will not do that. Instead, if I don't have the right index, it will go down here to the else, and it will raise an index error. And this is the same exception that you get if you have a list that's 4 items long and you try to get item number 22. It's going to tell you index error doesn't exist. So that's what we're going to do here. Okay, so I'm going to compile this so that we actually have that code ready to go. And now we're going to go and we're going to actually see if it works. And like I said earlier, if you do live demos, things sometimes don't work. That's okay. I'll just sort of smile and fake it. So I'm going to make my repeater object according to what I had specified before. I just want it to do hello 4 times. And then I'm going to see if it has a dunder iter method. Nope. That's not a surprise because remember, we only made dunder init and dunder get item. Okay. So then I'm going to say, well, does it follow sequence semantics? That's a little bit harder to say, but I can try there. That works. Let me try -1. Just while you're thinking along with me, -1, what should be the result? You can think about that. Okay, I got an index error, so that works. Let's see, 3, should that work? Yes. 4, again, for those of you thinking along with me, you can be thinking about what this should do. Index error. Okay, so we said 4 was our limit. We said it had to be less than or equal less than 4. So yes, we have this following sequence semantics right now. Okay, that doesn't necessarily mean that we've got everything, but it looks good. Okay, so then the question I raised before is, can the iter function use it to return an iterator? And it can. Okay, so while we still don't know what an iterator is, and we're not entirely sure of all the details on an iterable, we know that this class we just made is in fact iterable. It follows at least the two of the criteria that we need here. But the real test is, will it work in a loop? So you saw the class I created. It's not very big. Will that work in a loop? Okay. You can place your bets. This is where doing it live is more fun because some people inevitably say, no, it won't work. Some people, yes, it will. Well, let's just find out. It worked. I said I wanted 4 hellos. I got 4 hellos in a for loop. So this repeat object, that repeater class that I made, must be an iterable. I mean, it works. If it walks like a duck and quacks like a duck, it must be a duck. So that means, could I do this in a list comprehension? Yeah, I could. Any place where I am using Python iteration, this class I created will work just fine because it follows the protocol for iteration. Now, what happened there is that behind the scenes, we created an iterator from the repeat object. We'll talk a little bit more about that next. Since the repeat object can create items using integer indexes starting from 0, that worked. it continued until it threw an index error. That is, once we got to, to asking for slot 4, which was beyond the first 4 there, it threw an index error, and that's what stopped the repetition, stopped the iteration. And you also saw we used the same object, and we used it in a for loop, and then we used it in a list comprehension. And that means that each time we need to iterate over it, we got a new iterator. So that's the first half. That's the iterable part. So, strings, various objects, strings, tuples, keys of a dictionary, all sorts of things that we iterate over are all iterables. They are collections of data that we can sort of iterate over repetitively. And again, this is just a kind of a rehash of what we actually did. So what we did is we made sure we had a dunder get item. And this is what we needed for it to be an iterable, since we don't have a dunder iter thing. And then we raised index error when we were past where we wanted, outside the limit for what we wanted for that object. And we could have defined this without raising an index error, but in that case, we would have had an endless iterable. And a for loop would never end unless we had a way to break out of it using a break statement or something like that. There are cases where you actually do sometimes want to have an endless iterable. And there are some in the Python collections library. So as far as making an iterable goes, it really is just that simple. There's nothing more that's needed other than a dunder get item and index error. Those are the two pieces. But the second part is, what is an iterator? Python for loop, in order to iterate through something, needs to have an idea of what item comes next. Okay, you saw the iterable I created. It has no idea of what item is next. It just gives you whatever it is that's asked for. You want slot 0, fine, you get slot 0. You want slot 5, index error. That's all it does. And the for loop itself doesn't have any way of keeping track, right? It's only got for and in as the machinery of the for loop. So it's the iterator that keeps track of where you are and lets you figure out what is next. And it's the object that can do that that's an iterator. Okay, and an iterator has a dunder next method that is, its only purpose is to keep track of and then give you back whatever item is next. And you can get it by using the next function, or you can put it in any of the loops or comprehensions or things that we've seen. So that's what we need for an iterator. Again, to repeat, it needs to have a next. And if you call dunder next, you keep getting the items in turn. That makes sense. And when it runs out, it raises a special exception called stop iteration. And if you keep trying to get items from it, keep trying next, you're just going to get stop iteration over and over again. The other thing about iterators in Python that's kind of a little bit funky and makes this a little confusing is that an iterator, by definition, must have a dunder iter method. And that dunder iter method always returns it itself because it is an iterator. So when you ask an iterator for an iterator, it says, yeah, me, I'm the iterator. It just returns itself. That means technically iterators are also iterables. That's why we get so confused sometimes. But once you have an iterator that's been through a round of iteration and it's raised stop iteration, it's never going to be usable again. It's exhausted. It doesn't refresh. You can't use it in iteration again. It'll just keep raising stop iteration, which means it'll look like it's empty. So what I want to do is make an iterator version of what we just did before. So we're going to do the same thing where we're going to say, okay, I'm going to specify how many times it can repeat and what it's supposed to repeat. But we're going to make this directly into an iterator. We're not going to do the iterable way. So that means rather than the get item and raising index error, that doesn't apply now. What we need to do is have a dunder next method, which will raise stop iteration when it's done. And we need to have a dunder iter method that will return itself, so technically it follows the rules. So that's what this one does. And so we've got another class. This is a class to make a repeat iterator. Again, we start out with the same value and limit that I did before. And this is in dunder init, so we're setting values. So we're going to store our value for each instance of the class. We're going to store our limit for each instance of the class. But remember, I said iterators need to keep track of where they are. They need to know what's next. So the way we're going to do this is we're going to give it another method, instance variable called count, so that it can count how many times it's repeated, so it will know how far it is and be able to figure out what is next. Okay, like I said, we need to return, we need a dunder iter that returns self. That's pretty easy. And then we need a next, a dunder next. Okay, this is a little bit simpler. All we need to know is if our count hasn't reached the limit, we can add one to count and return our value. It's like, okay, you want this one here. Here's this one. I'm ready. I'm counting, ready for the next one. Okay, here's that one. Okay, I've raised my count. I'm ready for the next one. Oh, you want the next one? Oh, wait a second. I passed my limit. I'm going to raise stop iteration. So it either returns the value as long as it's, not beyond our limit, or it raises the stop iteration exception, which tells the for loop or whatever kind of iteration we've got going on, it's over. There's no more, just stop. Okay, you will almost never in normally working code see a stop iteration because it's handled behind the scenes by for loops, list comprehensions, and things like that. So I need to back up here. I need to make sure I do this sometimes. I need to compile this so that it actually exists. And then we can test it. So now with a repeat iterator object, I ask, do you have an iterator? It says yes. Okay. Will it work with next? Yes, it gives me a value. Cool. So now I want to see what happens if I call the iter function with it. So I created this object repeat iter, and I'm going to print it out. Then I'm going to call the iter function on that object and see what I get here. This is repeat iter, and print that out. And it'll be easier to understand when we actually see this in action. So basically, here's the object ID for my first object, and it's got this ID that ends in 90278. That's this one. I use the iter function on it and put it in this one. I print out that one. It has exactly the same ID. In other words, I'm just confirming we get the same thing back. That's what we expect. Okay, so I called next already, you recall? So here's my question for you. I'm going to run this. I hope it works. But if it works, how many times is it going to repeat since I've already called next on it once? Well, we can find out. And it's going to repeat 3 times because before I'd set it to do 4 repetitions. I called next on it once. That left me with just 3 more sort of in that object. And now if I run it, how many repetitions am I going to get? And actually, yeah, you want to put it in chat? I'd love that. So this time, so what do we get now? Somebody says an error. Any other guesses? Somebody says nothing. Well, okay, we've got a bunch of different options here. That's what I love. Let's settle this once and for all. Too bad we can't have bets. So I run it, and nothing is the right answer because it's throwing that stop iteration error, which is being caught by the for loop, and I can run this until we get tired. There, that's like 15 times, and we're still going to get nothing because this object is an iterator that is exhausted. And this is a simple-minded example, but if you think about a file iterator, if you open a file for reading and you're going to loop over it, you get an iterator. And once you get to the end, you're not going to get any more lines of the file until you get a fresh iterator. Same thing if you're iterating over database queries. It will behave the same way. And you can see a lot of people who aren't aware of this getting kind of confused. Wait a second, this just had my database query in it. I tried to loop over it again and it's empty. No, it's not empty. It's just an exhausted iterator. So that's an important thing to keep in mind here. So yeah, we can stop iterating over that. Now, what happens if I call next on it, though? If I explicitly demand the next item? Any guesses? Any thoughts? Okay, nobody is willing to hazard a guess. Well, let's see what happens. Okay, yes, you get the stop iteration error. Well played, well played. Because here now there's no for statement or comprehension or anything else doing iteration to catch it for us. So it's no longer silenced, and it will bubble up and say, yeah, no, you've got an exhausted object there. So that's pretty simple as well, right? I mean, that's all we need is a next that kind of behaves itself and an iter, and we need to have some way of keeping track so that it gets exhausted after one pass. So this is the inevitable thing. Thank you for asking, is there a way to reset an exhausted iterator? Because this always comes up. And you can make iterators that will do this. I have done it for my amusement. It is not something that you should do because anybody looking at your code, if they understand Python and iteration, they're going to expect the iterator to be one use only and throw away. So if you made your own iterator class, you could. I've done it. It's not hard. You could make it reset itself, but you shouldn't really ever do that. You can make any call to the dunder iter thing, refresh it before it returns itself would be the easy way to do it. But yeah, it's a bad idea. It would be unPythonic and it would surprise other people, or possibly even surprise yourself if you go look at the code a few months later. So I don't recommend that you do it. But it really would be, in the case of the one that we created, in the dunder iter method, I could just reset self.count to 0 every time it was called. It would work forever. Okay, now that's a way to make iterators and iterables. After showing you all of this, I showed you all of that so that you could understand the protocol. Almost never in practice do you actually make an iterator object because Python has a way to do it with a generator function. And that is way easier and way more readable. So if you've not heard of generator functions, they're functions that rather than return, use the keyword yield. And what happens there is that when we have a function like this and we call it, well, let me show you what happens. This time with the word hi, and I gave it the same limit of 4 repetitions. Basically what it will do is it will create an object. And this object is an iterator that will use this code. And basically you can think of it as every time there is a yield, it stops and waits until something calls next on it. So it goes here, the function does nothing until next is called on it, and then it will go next, 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 next. I can prove that by doing this. Wait a second here. And we'll do the same thing, hi, 4, and then here we're going to repeat this. So what I've done is I've pulled this out, and so this is the object that I get from calling repeat gen, my generator function. It's an iterator, so I can stick it in here and it will do exactly the same thing. There's no difference in the way it behaves. But that means now I can also do something like this. Let me print that there. Oh, I need to do something so we can see what's going on. There. So basically, I called a next on it, and I got the same sort of thing I would as if it were in the for loop. And then that means there were only 3 repetitions left in this object. So it went ahead and did all of those things. So that's the way that you do iterators without having to write classes like I did before. You just use generators. But it's important to remember when you're using a generator that really what it's doing is when you call this, it creates an object that then needs to be used with something that is in effect calling next on it to get the objects one at a time. Because that object will always sort of pause right after a yield and wait for the next time next is called on it. And you can do the same thing in Python with a generator expression. So if we use parentheses rather than square brackets, we don't get a list comprehension, we get a generator that returns a generator object same way, and it will do exactly the same thing. So that's the deal with Python. Iteration is a protocol. Anything that behaves the right way, that is, anything that behaves like an iterable, can have an iterator made out of it and will work in a for loop. And if you don't explicitly, most of the time we don't explicitly create iterators, they're created behind the scenes in a for loop. But you can sometimes use iterators as iterables. They just won't refresh. They're one pass through only, and then you need to create a new one, however you did. So that's what I got. I think I was close to time. I always tend to run on, but not too bad. If there is time for any questions, whatever, I'm happy to answer them. Like I say, I invite you to play around with this a little bit more and follow the same approach, experiment with things and try to understand how they really work, because it will make your code better if you understand what's really going on. So thanks a lot.
Thank you so much, Naomi, for showing us how iteration works behind the scenes, as you mentioned. It was really cool, and I see that some people were really involved. So, do we have any questions? Everyone is saying thank you.
Yes,
Great
my
examples. We have one question, that if the iter object gets modified with that next, will get modified with that next function.
The object will get modified in the sense that it will have one of its repetitions used up. And that should be about the only thing that calling next will do. Although it's possible that you could have, what should I say, that you might have something when you call next, whatever that process triggers might involve calling a database or doing some processing or doing whatever. So that might happen, but ideally you wouldn't want to have things where there were all sorts of side effects from calling next. So if that gets at your question, that's what that would be my reaction. Okay.
Yeah. Apparently, you solve it. Yeah, we have confirmation here. So yes. Somebody also asked, what other resources do you recommend to improve learning how to handle large data sets using Python? Besides your book, of course.
well, and a little bit of my book has to do with that. There is, I can't think of it now. I did see a series of blog posts on handling big data in Python. That would be part of it. And GitHub link in chat, please. That I can take care of real fast.
Thank you.
Well, I think, let's see here.
Of course, all the information will be shared in our social media, the presentation, the recording.
Right.
Please.
So, but yes, in terms of handling, there's more stuff coming out. There's an O'Reilly book on data wrangling, which Jackie Kazil, who's a board member with me for a while on the PSF, was one of the authors. So that's not a bad resource. As I say, I have seen a few blog posts coming out on big data in Python. So that might get you some tricks there. If you need to handle big data sets, like I've had to merge a 20 million line file, a 2 million line file, and a 5 million line file kind of in memory. There are tricks that you need to know so that you don't use up more memory than you absolutely need to. And one hint there is don't use pandas. For things like that, pandas uses a lot of memory. They know it, they admit it. It can be a bit of a problem. Okay.
We have one last question. If you have any recommendations to begin experiments in complex networks, please.
I don't. I think that is kind of beyond my area where I could.
Okay.
I think I would almost say, hey, if somebody's got that, I'd be interested too. It's not something I've done much with, so I would hesitate to say. Okay.
Well, okay. Do we have any more questions? I think that's it for now. Thank you so much again, Naomi, for
my pleasure
being here, sharing your knowledge with us. You have great experience, so it's pretty cool. Somebody else wrote, "Where can we buy the book?"
I will get that and put it into chat as you go on. So yes, that will be fine.
Okay, perfect. Thank you. Thank you so much, Naomi. We will continue with our second speaker. Her name is Julian Sarah Joseph. She's gonna talk to us about COVID-19 data visualization using Python. She is a graduate of computer science and engineering degree in 2016. She was also a Grace Hopper Scholar in 2015. She is also a Woman in Data Science Ambassador for Mumbai since 2018. She has been working for 4 years in fractal analytics as software engineer, using data science and machine learning to aid human decisions. And as a full stack developer, she is always hands-on UI, backend, infrastructure, and data science. She also enjoys using technology to solve problems by building applications or some scripts. So welcome, Julian, sorry.
Thank you so much. Hi everyone, thank you for joining. If you were in my country, this would be pretty late and I would be thanking you even more. But I see that a lot of you guys have joined from multiple places. And let me try sharing my screen.
Perfect.
Is it visible?
Not so far. Yes, now we have, yeah.
So I was actually happy to see a lot of smiling faces since we're all locked in our homes for about 4 months now, 4 to 5 months. I don't know when was the last time we went out. So this, I really like the fact that we are having these meetups, and thank you so much for the opportunity. Fair warning, I am not as no match to the previous talk. Or Naomi did she has a huge, great background, and I myself got to learn a lot from the talk. So this is going to be my attempt to help out anybody who is interested in data visualization, and also something that has helped me stay calm in 2020 during this lockdown period. So we're making use of COVID data this time. So before we begin the coding, just a brief introduction on why would anybody want to do data visualization. So currently, I think all of us, if you could just quickly put up in the chat, how many of you use Fitbands? Alexander, you might have to tell me the number if there's anybody telling yes or no, because if I switch my screen, I won't be able to see this. How many of you use?
We have a couple of people mentioning that they use.
So there are like a lot of ways that we track data, keep adding data. I mean, there are people who are measuring the number of times you have searched a particular item. There are people measuring what tracks you listen to. Basically, there's a lot of data, overwhelming amounts of data that's coming up. And all throughout this pandemic, I'm sure all of you have been overwhelmed with the number of cases. Every day you wake up and you're like, okay, the number of cases for today is this, and what has been the case all around the world, and so on. We have basically, this is a lot of data. And regardless of the fact of what your current job is or what your next job is going to be like, we definitely have to make use of the data available to us and try to derive insights from this. So coming from a data analytics background, my company Fractal is making a living out of this. Like, we try to drive human decisions based on the data that we have. So we might have retail companies, clients, like who have consumer products, and they might want to plan their next marketing campaign based on their sales data. Okay, so maybe a lot of people are buying toilet paper, or maybe a lot of you are subscribing to Netflix. So there's a telecom operator that's trying to maybe give you an offer there. So that so all of this data can be used to create meaningful decisions, meaningful insights on which you can make a decision. And regardless of the domain, like I mentioned, just telecom and retail, but that's not the case. Every single company today is a data company. you do not have any sector or domain that does not have some kind of measurement or data collection happening, be it banking, be it fashion industry. Every single company is a data company. So just like you have the worry that, okay, maybe my company's data might be hacked, similarly, your data can be actually made use of to derive insights. And that is why we're going to be using visualizations to convey the message across. Now, you might be a developer or a business professional or whoever you might be, you can make use of data visualization to actually present your facts in a jiffy. Basically, all of us can. I personally maintain a budget book for our household. So at the end of 6 months, I would show to my husband saying, so this is how our savings look like. This is how our expenses look like for the past 6 months. We should be making some cuts or changes, maybe cancel a subscription. So anyone here, and no matter what your profession is, I think Joha mentioned that we are a bunch of data scientists, web developers, and she mentioned a bunch of different domains that we come from within this group. Data visualizations can be made by anybody, but with basically the objective of getting the message across in a very quick fashion. And I'll get to the point when I'm showing you my code. I would also like to suggest if any of you have read HBR articles, Harvard Business Reviews, they have a series of webinars called, the person is Scott Berinato, the person I've named here. He has written this book for HBR called The Good Charts. So he says that people who create good data visualizations are good data visualization consumers. So every time you log into Facebook or Twitter, you have these n number of charts, like 5 visualizations that summarize the presidential campaign, or the one chart that will get you machine learning or linear regression, or make you understand the anatomy of a country, or regardless of what the topic is, you have a lot of visualizations being flooded into social media every single second. And the only way you can consume that in a good fashion is if you have had hands-on experience on creating good data viz. So just before we begin coding, I'll just brief you through what are the different types. We have line charts, bar charts, and scatter plot. And for sometimes, there might be cases where there are different, you might have some of you might want to go to the other end of the spectrum and try to put in a lot of data. I could crowd my bar charts with labels, with a lot of different colors maybe, and sometimes it would be more efficient to just show what are the peaks, just draw a line chart that goes from Jan to March here. And sometimes it might be better to just show them in a dot plot. Like I've not shown a dot plot here, but a dot plot would be just a basic line with these dots. So that intuition comes with experience on like what chart would show, would suit your data set the best. But it is also an important decision. It would be better to, I would try to go through some of these best practices that we should try to follow when we create these visualizations. And sometimes it is, sometimes you have so much data that you might have to, instead of printing them out in a chart, tabular form is also a form of data visualization. And sometimes it's one of the most efficient ways to get your message across on what does the total look like, what does the average look like. So the last thing that we will be covering is the maps. We'll be having scatter plot maps and choropleth maps. Moving on to the code. Anybody who is, so we've gone through the who should do it and why we should be doing it. Before you begin this, I think I've just broken it down into 5 steps on any visualization that you would want to begin with. Firstly, you need to have with everything else in life, you need to have an objective for your charts. Second is to find a good data source. The third is to find, so in Python, like now we mentioned, we have pandas and we have other libraries called matplotlib or this plotly express. There is Seaborn. There are multiple libraries out there that will help you with your data visualization. If you have figured out what library you want to use, then you might have, as your fourth step, you might have to change the data source, the data that you have obtained. You might have to transform that into a different format for you to suit that particular library. So make sure your data set is from an authentic source, because after you've put in all the efforts of making the transformations, plotting your chart, you don't want to be pointed out that your data source itself is incorrect. So once you have these two chunks ready, the only part you have to do is the transformation. And that's it. We can then go ahead and plot our chart. So as I mentioned, these would be the 7 types we'll be going through. Here I have taken the Johns Hopkins University's data set, which so what I'm trying to show here is a Google Colab. If anyone of you does not know about it, it is very simple to use, and it has a lot of features, which I'll be showing you as we go about. One of the easiest ways to get data is if you have a GitHub source and you have the link where it is accessible, the CSV is accessible here. All I've done here is use the pandas function to read that CSV, and this converts that CSV into a data frame. So this is how your data looks like. It has a column called countries, and that is listing the confirmed cases, the recovered cases, and the unfortunate deaths for all of these countries, all the way from January till July. So I ran this notebook sometime earlier, but that is why we have it only till July 19th. If this data set is refreshed, we would have more dates being added. Moving on, we then try to now, I've tried to reduce. So for the objective, my objective currently is to plot a line chart using pandas itself, and we are going to plot it for just a few countries instead of plotting it for all these countries, because then that's going to clutter my entire chart and I won't be able to really make sense out of it. But you can definitely go ahead and do it. But for this talk, we're going to just focus on 2 countries. I've created a list here, which is going to focus on UK and Sweden. So, and here, what we are going to do is, all I've done is I've created a COVID as a copy of this data frame that I had actually gotten from the data set. Here we are now. Okay, now I've pivoted the data frame here. Now you might want to know why this is being done. We will see why this is going to help us later on in the x-axis and the y-axis. Now, once we have these countries in place, and that is saved in the data frame called COVID, we are now going to find, so I have created a dictionary called populations. Basically, all I did was Google what is the population for Sweden, what is the population for United Kingdom, and I've created a dictionary out of that. Based on this, we are now going to reduce the number of confirmed cases per 1 lakh people, and that is now going to give us, instead of plotting these numbers as it is, we're just going to divide that for per capita. Once we have that formed, so this is what I meant by transforming your data. What you have, you might want to make something else out of it. If you had noticed, I had, along with pandas, I had also imported matplotlib in this. And the reason I've done this is basically just to make sure I can style my graph. And there are a lot of styles available. So plt.style.use. And when you're in Google Colab, what one of the best things that Google Colab does is when you hover over a certain function, it will actually give you a tooltip. It's not coming right now, but it should. When you hover over any function, it'll actually show an entire manual. I am surprised it's not coming when I want it to. Okay, moving on. But it does come in, like you have that entire manual for what this function expects in terms of arguments, in terms of what is a required argument, what is an optional argument, and you can go through that manual and understand. Or what I would always recommend is go check out the documentation of any library that you use. If it's pandas, go check out the documentations for pandas, or if it's matplotlib, then that. Here, what I was trying to get to is the styling. I've used a 538 styling, which actually makes your chart look really pretty, like how you see it in magazines like Economist or any other magazine that you might go through. It takes care of that styling, and I would recommend you go through the website of 538.com as well. They have beautiful visualizations that have a beautiful style background. That is what we have used here. That is the reason I've imported matplotlib. But we are making use of pandas data frame .plot function itself. This .plot is within pandas that allows you to plot whatever that data frame is going to have. Further on, I have just created an object out of this. I have in the plot, the function plot expects a figure size. These are optional things. You can either give them or not give them. It's up to you. And if you had noticed, I'd also created a dictionary called colors for my country, so that we'll have different colors for different line charts for different countries. So I've given 2 different colors here, and I've also listed that here in my plot function. And I've decided how much width I would want for the line charts, the line. And if I want a title for it, so that's how it looks like. I can give it a title there itself. The chart object now I can make use of the chart of the y-axis, and these labels can be set. So this is how basically your line chart would look. So from February till July, Sweden has seen a rise. And if you notice, we will be going in detail about this. March, and when I plot, so a line chart has this drawback. You can't actually see what was the scenario in this area. Like you can't actually see what was happening here, when it actually start rising, and on what date. So we'll go into detail on other charts where we actually see this. Another chart is again a line chart, but we are making use of matplotlib here. So this is how the chart looks like. But what I've tried to do here is in matplotlib, I hope this is visible. So again, I've made use of the same exact same data set. I'm making we are now zooming into just Sweden. This is the countries that I've used, and matplotlib.plt is what we're using. We have decided the figure size. We can decide what axes need to be used, and from the data frame, I have now zoomed into just a few of those values. That is why we have an x-axis and a y-axis, because we are now going to focus from June till July. We have let go of all of the other months, and that's what I've done by iLock here. I've taken a subset of that data set, because we're going to plot it only for that particular line. And in addition to all of this else remain the same: the x-axis label, the y-axis label, the y-ticks. These by ticks I mean these lines here in the chart. But what you can see interestingly here is you can see these y-axis numbers, like what was the exact number of cases on that particular day. And in order to do that, I've used a for loop where x and y, these x and y are actually the values that need to be plotted along the x-axis and the y-axis. And here what I've done is I have made sure that I print that particular, the string j refers to the value of that y value, but I've made sure that the position of j is, say, it should not be coinciding exactly with that blue dot. It should be a little above. So I've done +100, and that's why all of these numbers are placed above. That's it, and you can further go ahead and use one of these wonderful things that matplotlib allows you to do is annotate. And I have used this annotation here that says, hey, look. As you can see, whatever, supposing you are on a marketing presentation, you want to use something, you want to point to one particular point. Okay, this is where we relaxed our lockdown, and that is why the cases have increased from 65,000 to 67,000. That is one way you can change this, and go ahead and feel free to make use of any colors on the background. You can change the annotation look. So here you can see I've used annotation. The arrow props have to be given as a dict. And do not worry about how I know how to do all this. All of this is written exactly how to be used within their documentation. If you just search for matplotlib annotate, you would be directed to their official documentation. That they are the most simple ones. All official documentations are what I would always recommend. So here we have given what color to be used and what width that line, the arrow should be. This was another kind of a line chart. The next basic chart is a bar chart, definitely. Now in a bar chart, what I've tried to do here is use a Sweden country's specific data, where we had the display name. We had two columns called display and population. We have several columns. I can show you them here. Yeah, this is the data set. We have region, display name, population, the latitude and longitude, and for all of these dates, we have the recorded number of cases. This is our data set. Now we're going to make a bar chart out of it. So before we begin plotting the final one, a simple bar chart would look like this, where here I made use of a library called Plotly. In Plotly is a very simple, but it makes interactive charts, as in I can zoom in or I can zoom out. I can double click to go out. That is why Plotly it has a lot of animations. It's a really fun library. So, and the syntax is really simple. What I've done is I have created the data frame like before, read a CSV, created a data frame, and moved on to deciding what I have to plot in my Y and X axis. I've given a basic title. So as you can see, we have Stockholm with the largest population. Just keep this in mind. I mean, this is why I said data visualizations help you. You can quickly get to the crux of the matter here. I've shown you this data set here. We have a similar data set. That the above one was for confirmed, and this is for deaths. If you see, these were for the confirmed cases. These are for the deaths. It's a very similar data set. I just have one more column additionally, and I have now created a separate list for the confirmed values, the deaths, and now my objective is to show you instead of. So what were we trying to do above? We were trying to plot what are the confirmed cases. We could actually plot a different line chart for each of the values. Like if you remember, initially we had confirmed, recovered, deaths. I could plot different line charts for different cases, different columns. But instead of doing that, if I were to create a stacked bar, I would end up having a complete picture in one go, where I've currently focused only on confirmed and deceased, and there was no recovered data set for Sweden. But in my data set, I have two columns, and instead of plotting two different line charts, I've now created a stacked bar chart. So this is going to give you a very a close-on picture on how does the country-wise breakdown look for Sweden. So if you remember, the maximum population was for Stockholm, and here is where we have the maximum number of confirmed cases as well. And there are some regions where we have 0 deaths. As you can see, I do not know how to pronounce these names. You guys might be aware. I chose a Sweden data set so that you might feel familiar. What I want to focus on here is the colors that I've used are those that are colorblind friendly. So there are a lot of people. I could have easily gone ahead and used the usual red for diseased, green for blue for confirmed, and green for recovered. That is how I had plotted it for a different chart. I could do it for the above one, but there are a lot of people who are not able to see red as red. Like if I were to show you a traffic light, if you were not colorblind, you would see red, green, and yellow. But for some people, it looks like this. So every time you create a data visualization, I would like to keep you recommend to make it as inclusive as possible. There are people who see red as I do not know what to call this color. It might be a slightly green. So it is highly recommended that you would go for a blue-orange. I myself have one of my clients who is colorblind, so we often go for a blue-orange setting usually. So make sure you keep that in mind. And The bar chart plotting in a matplotlib is very similar again, just like how we plotted using plotly. We use a plt.bar. We have given the x-axis as the y-axis as the, I mean, we have given the different, we created these confirmed and death list, and we've given those two lists here. And that is how we have created this. And again, note how we have used for loop to print what were the y values. So I'm definitely going to share this notebook, and you can go ahead and play around with it, see whether you can change the colors and see how you can change the positions of each of this, or change the colors of the labels, the ticks, and so on. Another data set here that we've used is a tabular form, but instead of just seeing it like this, Pandas allows us to add somewhat color to the same the table here. The table is basically showing you the number of deaths confirmed and who are currently in hospital. There's also a population column. I have shown how we can add colors. It's a gradient color where it shows the maximum number of deaths have occurred in Stockholm, 2,303. So color basically helps your visual, your sight zoom into that particular point. We are all visual beings. There is nobody here who is a person who is not a sight-oriented person, and we connect with color and sight, and that is why I've just added a bit of color. But if I were to create one more row that says total, that will actually help drive. So this data set did not have total, but if there was a total one, a tabular form of data is actually very useful in some cases. Instead of sometimes it might be easier to go through the numbers directly. But I know sometimes that is a little boring for a few of us. So I've used the same set, the exactly same data set here, and created it in a 3D version. So personally, I find tables boring, so I've gone ahead and created a 3D scatter plot for you. In this here, I've again made use of the library Plotly Express. Note, if you want to install any library within this Google Colab, this is how you would do it. I've run this cell before, so Plotly has been installed here, and that's why I could import it earlier as well. Here, what I've tried to do is, instead of just plotting these numbers as it is, I have chosen to find out what is that maximum value and what is the minimum value. Because if I were to just plot it, I tried doing it actually, and everything was in such a way that I was not able to see the difference between the scatter plots. So instead of just keeping it as a plot that you can't relate to, I found out what were the maximum and minimum values for each of the confirmed death, and there was a value called FHM at hospital, basically, who are the people at currently in hospital. So these are my three axes: deaths, confirmed, and at hospital. And for each of these values, if you can see, I've given a range. What should be my range for X? What should be my range for Y and Z? So I've given these values. So it's a list, and if you do a dot max, you can get the max value. It's basic Python. There are a lot of other arguments that you can give within this scatter plot, and it helps you understand what is the current scenario in a very, I mean, it's not a thing to joke about, but it helps you, stay calm, and it's a fun visualization. I mean, I love 3D scatter plots, but yeah, this was for the 3D charts. There's also sometimes I can, like, even while I was creating this, I found 3D to be not really necessary in understanding what are the numbers here. Also, please note that this gets automatically scaled to what your numbers are. If it's 300 to 1,000, and here, that is one of the reasons I had chosen to make the max and min. Instead of seeing it in a 3D chart where it's really confusing, you're not able to get a picture about which region is actually in the maximum danger, I created a 2D chart. So that actually gives you a quick idea. Like, it was hard, and you're actually playing around with it. But here in this case, just like how a bar chart would do, a 2D scatter plot did the trick here. So I can quickly understand that, okay, the green is the largest dot here, and that is relating to Stockholm. And one of the good things about this is you can actually click on one of these and it'll just show that particular uh, plot alone. Like I've clicked on Oribro. I'm sorry for if I'm pronouncing it incorrectly. There's a place called Sormland. Um, so if you click on one particular region with this, I can actually see that. And if I double click on it, it goes back again. So these are the benefits of using Plotly. It's very interactive. I can zoom into a specific set of regions and then hover over them. So this was the advantage. Like, this is what I meant by you need to have an intuition on what works and what doesn't work. If a 3D is not working, it is not working. You need to move to something else. Another thing that I found very interesting is creating unit plots. Sometimes in order to drive home the lesson, supposing these are the number of hours that I'm losing because of, maybe I'm not productive while we're all working from home, and a lot of companies have noted whether their employees are productive enough or not. Maybe there are IT issues that are actually blocking you. So based on that, you might want to drive home the lesson, and sometimes these circles might not really drive home the lesson. So some people try to make use of units, as in instead of showing a circle, they might show you a dollar sign. The amount of revenue loss that you're having because of IT issues, your people are not able to work, and so you're losing that much of revenue. So if you use a dollar sign there, that's called a unit plot. Or in case of lives, you might want to show people. So I have tried to get hold of another data set. Again, these are all readily available on GitHub, so these links would be available. Here, this is a data set for Italy, and in this, what I've tried to show is it's a scatter plot only, but instead of showing you those line charts, these dots actually give you. It might give a shock, but that is how the case has been, as we've been seeing a rise since somewhere between February 24th and 25. We had like 0 cases before this, and as you zoom into this, these each of these lines are, as they're increasing, you can see these numbers are, it was 0 on at 1800, and then as you move on February 25th, it is increasing. Like in one day you went from 0 cases here till 125 cases. So showing this as a unit plot, it's a scatter plot, I completely agree. It could be, so imagine that this was within a bar chart. Supposing these were bar charts for the rise of cases, but still if you were to use units and plot it by where every circle represents a life, that sometimes is more useful in stressing on the fact, on the objective of your data visualization. So again, this is extremely useful in understanding what have been the cases. And these yellow lines that you see these are the colors that I've used for the regions. For different regions, you have different colors. So region number 22 has this yellow color, and region 5 has a purplish color. So go ahead and try playing around with these things. Maybe you can use you can use the provincial data as provincial column for your color. That'll have a different, based on the numbers, these colors would be actually useful. So this is how the cases have been increasing in Italy from March. But again, it was not all the way in January, like we saw for China. But here it was increasing since February 24th. 24th also is 0, and it moves on till 25. So this is another visualization that I wanted to introduce you on. And we're coming on to our last set of visualizations for today. These are the map. Okay. Yeah. We have a scatter world map and a choropleth map. So in a scatter plot map, we have again made use of the initial data set that we had, where we have countries and their rising from January till July. I've used till July 4th here. Again, here we're making use of Plotly. This is a scatter plot where we have made use of the data frame here for per country. We have plotted it, and we have, as you remember, we had the lat and the lon. These latitude and longitudes are very essential for any map that you would want to plot. They are definitely a requirement in that data set. So make sure you have that if you want to plot a map. And here we have made use of a scatter geo. You have multiple varieties of charts that you can plot. It could be a bubble chart. And one of the things that we find restricting as engineers is that personally, I would find these squares to be a little weird. So I might want to make my own data visualization library that will allow me to change these values. A lot of things are possible. A lot of these configurations can be changed. The size, the opacity, the colors can be changed. Currently, I've used auto scale to be true. I could make this false and give my own colors. But every library comes with its own cons. Every library has its own limitations, and you have a certain limit that you can actually change. But and that's why people end up making more libraries. So if you feel this is not enough, this is not a really good map, you could go ahead and create another one of your own with maybe another library, or maybe end up creating a library of your own. So that's one form of a world map. The second form of a world map that I wanted to show you was using the exact same data set here, the lat and lon. It's called a choropleth map, where you have colors as a gradient color that we have used here instead of these maps. Again, here I've made use of, you can see Go is the Plotly. You have this graph objects, which I've actually used an alias of Go. Plotly itself gives you these graph objects. From that, I have used go.figure. This is also, so all of these starter code will be available in the documentation itself. Like if you go to Plotly documentation, you would actually get these starter things, and you can then go ahead and play around with, okay, maybe I want to change the go through each of those arguments, what you would like to tamper with, and then make sure that you can see a different variable. So here I have made it false. I've made the auto color scale and the reverse color scale false, and I've given my own set of colors as a list that should be used, because what came initially had a lot of red and had a lot of yellow. Again, in order to make sure that this is a very colorblind friendly thing, I have made my own set of colors here, and I've given that as a list. So this takes that as the list to be shown. That's it from my side. As a parting thought, I found this HackerRank article that was actually trying to track the number of female developers that are there who have actually participated in their contest. I'm not sure how many of you code in that. It's something that helps you improve on your coding skills. And I often try to, they have these badges that you would like to do. They have a lot of, for developers and for companies, and they have a lot of these interview competitions and hackathons, basically. So they had this data set, and this is a very old data set, actually, 2018, 2 years ago. Seems like ages ago. But here, what I saw was, I tried to, instead of showing you the numbers, I can show you the chart. What I saw was we have 5.7 as our number of women who have taken part in competitions in Sweden, and I feel it is Magenta Codes, and maybe there are other groups. We definitely can increase this number to a lot bigger number. We have, we saw the population of Sweden, and there are a lot of women here. We definitely can improve in this. I'm not saying we should use HackerRank, and this is just a biased data set here because very few people use HackerRank, and this is an old data set. But I'm actually, this is a shout out to all of these women who are organizing this. Computing, there's this very famous quote that goes about to say that computing is far too important to be left just to men. And this is having no offense to any of the men who have joined us today, but I would really encourage and actually applaud your efforts in organizing these such groups of workshops, basically, where we can actually improve. And the more diverse our teams are within your companies as well, the better your results will definitely be. Especially when we're working with data, it is highly malleable. Supposing if you have a team that is having people who are only say white men or white American men, you might have results having, because so there was a statistic that said a lot of these cars are designed by keeping only men in their mind, and when women are driving those same cars, they end up having 47% more life fatal injuries, because these cars are not designed for men, for women. So when you are a part of these design teams, when you're a part of these data science teams, you have an influence on what kind of results are derived from that. You have an influence on what charts are going to be built. So when women from different backgrounds are a part of these teams, know how to code, know how to create these visualizations or decision driving things, you end up creating better results. So a shout out to everybody who's making time, taking out time to create such platforms. Thank you for giving me this opportunity, and I'm sharing all of my resources here. I've for this entire talk, I've ran through all of these things, and I've created a blog that kind of breaks down each and every line of the code. So that has also been linked here. That's it from my side, and kudos to all of the organizers and for everyone who's joined. Thank you so much.
Thank you, Julian. Amazing, amazing talk, and thank you for the shout outs there. We have some time for questions. So let me see. You mentioned in the beginning of your talk, HBR webinars on data science and data biz. How could you please post the link? Yeah.
Sure. If I don't find it here, I'll send it to you. Would that work?
Yeah, for sure. We will, every resource that you and Naomi share with us, we will share in our social media. We have a resume of all of our talks and the recording, so the resources are there.
Sure. I'm trying to search it. It should be here. It's called the best practices and the worst practices. Yeah, I found it. I'll share this.
You also mentioned at the beginning a library for styling the graphs, magazine level, as you mentioned. Can you also share the link to that and tell us more about?
Yeah, that's added in my notebook.
Okay, great.
It's called 538, and there are a lot of such stylings. I've added the 538 link within the notebook itself.
We have another. What is your favorite graph, like type of graph to analyze and display data, and why?
My favorite graph. So like I mentioned, I like playing around with 3D charts, but it has its own drawbacks. And the point is, you can't have a favorite chart. It depends on the context of what are you trying to present. The objective of your chart always depends on what are you trying to answer and what kind of a data set you have. So it's very contextual, and it might keep changing. Sometimes a bar chart does the trick, or sometimes I would have to resort to a tabular chart. So it completely depends on what I'm trying to answer.
Okay, thank you so much again, Julian, for your talk. We have another question. Sorry. What is your best advice for someone who is starting in data science?
Data science. So everybody who is out into data science today is basically jumping onto all of the cloud. So every cloud currently has these automated set of tools that you don't need to know any algorithm or math or statistics. All you need to do is drag and drop the models that you have. It could be a logistic regression, or it could be a neural network. But if you would like to just start off, I think go ahead to any Kaggle competition, and Kaggle is a place where you have competitions for prizes. You would actually have prize money there, or you can have it for just for learning. And these Kaggle competitions actually help you, give that introduction to you on what does it look like. You might get a data set, you might have to predict a certain thing, or you might have to forecast a certain thing. That can definitely be a starting point for your career or data science career. But I would recommend spending some of your weekends studying the math and the stats behind this. And it is only in recent times where we've started calling it data science. It used to be just plain statistics. logistic regression does a lot of things that are enough for us. You don't need to go ahead for neural networks and AI. Logistic regression can actually do wonders. So there's this book called ISLR. I would recommend that if you're beginning statistics. And for math, there's this YouTube video playlist called Essence of Algebra. That is also a must.
Thank you so much. And yeah, that's good. Great advice on always checking the basics first before going into an entire AI algorithm or something like that. So yeah,
absolutely.
Thank you so much. Well, last we have we want to invite you to our next workshop. This is more focused on web development, so it's AMP, web components to easily create pages with great experience on the web. This will be a Google Study Jam session with Ben Morse, who is a Google developer advocate and a full stack engineer. So the session will be held on August 12 at 6 p.m. Register in the meetup group, and all the information will be there on our social media. And last, well, the feedback for us is also very important. So please let us know how was your experience. We are already sending some surveys, and all the links will be also available in our social media. Some surveys for you to fill about this experience, and what other topics do you want to hear, learn. If you know a woman, if you know somebody who wants to give a talk and teach us some other things, this is an amazing opportunity to do so. And last, well, we want to thank again the speakers, Naomi Cedar and Julian Sarah Joseph. Amazing talks, great tips, also in inclusion and very technical things. So that was really, really good. We want to also thank the organizer team because, of course, they made everything possible. And last, you guys, our attendees, all the women that sign up for the meetup, and also shout out to all the guys that are here supporting and helping women to build each other and lift up. This is an amazing community that we just want to uplift each other, and that we actually help closing the gender gap in technology and in all the STEM fields. Please suggest ideas, and thank you so much. See you in the next talk, and stay safe, stay home. Bye.
Bye.
Thank you. Bye.
Bye. Thank you.
Thanks, everybody. Bye-bye.
Thank you. Bye.
Bye. Thank you.
Thank you, guys. Thank you, everyone.